When we teach architectural history, we revere forms born in the cold. Think of the sleek lines of the Bauhaus, or the iconic Californian glass box. These structures follow a strict geographic logic. They were authored for climates where the winter wind was the enemy, and the sun was a scarce, welcome guest, invited in through expansive panes of glass to warm the interior. For 70 years, we exported that vocabulary wholesale to the equator. The sealed glass office tower, conceived for the light of Chicago, was built 3 degrees off the equator. Without the seasonal cold to offset the solar gain, these forms function exactly as their geometry dictates. They become solar ovens. We answered the mismatch between form and climate the only way a sealed box allows, with more air conditioning. This IEA chart shows energy demand for space cooling more than tripling by 2050, as global air conditioners climb toward 5.6 billion. To reach that, we must sell 10 new machines every second for 30 years. That massive electrical toll and the waste heat it expels is a way of paying for a design decision made wrong upstream. Every AC unit is a mechanical correction for a form conceived for the wrong climate. This is the context for Singapore Design Week. Singapore is warming at roughly twice the global rate, with an urban heat island effect that can leave the city core 7 degrees hotter than its greener edges. Before mechanical cooling existed, tropical buildings solved for heat in their first moves. The colonial veranda used deep overhangs, louvered shutters, and raised floors to hold an interior 6 to 10 degrees below the outdoor peak, without any machine at all. These are the pillars of passive design: orientation, shade, cross-ventilation, and thermal mass. You cannot retrofit a draft into a sealed box. These decisions are made at the concept sketch, or they are never made at all.
Singapore has treated this as policy, not taste. Its Lush program legally requires new developments to replace the greenery they displace, pushing gardens up the facade to act as thermal infrastructure. Buildings like Campum Admiralty are conceived from the first sketch around the heat. It functions as a cascading stack of naturally cross-ventilated layers, supporting more leaf area than the land it stands on. Passive design is not a total substitute for cooling in extreme humidity, but climate-responsive form buys you a smaller cooling load. Smaller by design is a necessary counterweight when the alternative is to add cooling capacity equal to the US, EU, and Japan combined. As heat waves push London, Seattle, and Munich toward temperatures their building stock was never drawn for, the temperate world is acquiring a tropical problem. The shading, ventilation, and material choices Singapore has spent decades systematizing are becoming the global default, not the local exception. A building drawn for the cold and cooled by machine, and a building drawn for the heat and cooled by its own geometry, can look identical in a render. They are opposite decisions, taken at the concept phase, and only one of them remains viable in a hotter world. Deciding which climate you are really designing for before the first surface is drawn is the moment where the actual logic of the form is established. That concept phase, the choice of what problem the form is actually solving, is exactly where we work at Depix. Design decisions are cheap as a sketch, brutal once tooled. See every angle before you build.